Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2874, maximum value of an order triplet 2. Yesterday we have already solved a problem which is maximum value of an order triplet 1. So what's the difference between this 1 and 2? There is no much difference. If you read the problem statement, it's completely the same. It's just the difference in the constraints. In the maximum value of order triplet, the constraint is the length of the array is going till 100. And the problem is that from the array we have to pick three elements at indices I, j and k such that index I should be less than index j, should be less than index k, and those three values should give me the value with this formula. So if we apply this formula, we'll get the value, and ultimately what we have to return is the maximum value. The maximum value of any triplet of these indices we can form. So we have to choose three indices in such a way that all of these three indices are in the order, and this value should be maximum. And here the array length is 100 in the problem 1. Maximum value for the triplet 1. So if the length is not too much, we can directly do the brute force, like running the three loops. First loop for I, second loop for j, third loop for k, and then capture the value. Whatever is the maximum value, just capture in the maximum variable and then return it. So this is something we can do in the problem 1. But in the problem 2, there is only one difference, that the problem statement is same, but the length of the array will go till 10 to the power 5. So we can't afford an algorithm which is a brute force one running through three loop nestedly. To optimize this, we have already used an approach which is based on prefix. What we did is we have to pick three indices, and if we try to apply the greedy way, there is one index on the left side and nums I, one index of the right side nums k and nums j. If we just have a look on the j value can go from second index to second last index, 1 to 10 minus 2, and nums I and nums k we can pick greedily. The whatever is the maximum value. So in this case, we will be able to get the maximum value of this expression. So what I did is I picked two arrays. First array is left maximum. For any index I, whatever is the left maximum, including I, will be stored at this position, and maximum on the right side including I will be stored in this array. So at the time of checking the expression, so this is something I have filled these two arrays and I will be able to get the result. So this is the same approach we can use directly because it is a linear time solution, and with these constraints where the nums.length is going till 10 to the power 5, we can have a linear expression, linear or time complexity. But if you still want to check the whole explanation, you can have a look on this video, maximum value of an order triplet 1. In this video, I have explained this approach in detail, how the pre-processing is helping us to save time. And we'll directly code this approach. I will just add the link to this video in the description below. If you want to have a look at the approach, you can have a look. Okay, let's code it directly. What we decided is that we'll be having two arrays, left maximum, right maximum. N is equal to nums.length. Let me zoom a bit. Nums.length, integer array, left maximum, new integer array of size n, and the right maximum will be of the same size. For the left maximum, it will go let's just start from 0. It will go till third last, because if third last is I, second last can be j, and last can be k. Less than equal to n minus 1 is the last, n minus 2 is second last, n minus 3 is the third last, I plus plus. And what about the right maximum? Right maximum value will start from n minus 1. N minus 1 is something we require. I greater than equal to 2. 0 and 1 can be for left two elements, I minus minus. In this case, I have that idea as well, left maximum of of the zeroth element is the zero element itself, because there is no element on the left side. Nums of 0. So if we have captured this, just increment here so that we can directly use index -1 in this. And what about the right maximum of n-1? It will be same as nums n-1. So n-1 is already captured, just n-1 -1, start the loop. And what is left maximum of I? Left maximum of I is equal to math.maximum of left maximum of I-1. Maximum value so far, comma, compared with ith value. Same here, right maximum of I is equal to math.max. Right maximum value so far means I plus 1 and nums I, because we are moving from right to left. Now these two values are with us, and now I have to just run a loop. I equal to 1, I less than equal to n-2, I plus plus. What I will be checking is I have to capture the result first of all. Math.maximum of result comma our expression, and in the end just return the result. And what is this result variable? A long variable, because we are using multiplication. Just to tackle this constraint, nums.length less than equal to times power 5, we are not able to afford and cube time complexity. We have to do it in a linear time, and this approach is giving us a linear time and linear space. You can optimize space as well, that you can explore by your own. Let's do this linear time. First of all, whatever is the we have to pick 3 values, I, j and k. So see, I, j, k all are the indices actually. So whatever is the maximum value on the left side, whatever is the maximum value on the right side, minus my current element. So what can be the maximum value on the left side of including I? Not including I minus 1, including I minus 1. That will be this. I element is my j, nums of I, into long R max of I plus 1. See, current element is I. I is something I'm taking for my j. So this will go from all the valid indices. These are the valid indices. And for every valid indices, let's say I pick 2. I pick 2. This is the 2. So whatever is the maximum value so far till index 1, that is here. Whatever is the maximum value so far from right till index 3, that is this. So this expression is fine, and now I can directly run over sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Bye bye.